Now we have a very nice word algebraic problem, and we're going to find this one to be quite enjoyable. When a number x is multiplied by 2, the result is squared to give a new number y. When a number x is multiplied by 2, the result is squared to give a new number y. So we need to write that in algebraic form. So we have a number represented by x. So we have x, we're taking an image of it right there. So we're taking it from the statement of the problem exactly in the way that it is. Is multiplied by 2. So we may say x times 2. But we know from the very foundation that x multiplied by 2 is 2x. So let's not grope in darkness for that one. So 2 times x is equal to 2x. So we have 2x right there. The result is squared. So after multiplying by 2, the result is squared. And we will have a caption mentioning that. So if the entire thing is squared, that is what we really want. So the result is squared means that the entire expression is squared and not only the x. The result is squared. The entire result is squared. Therefore, not only the 2, not only the x, but the entire 2x is squared. To give a new number y, the new number y will be the result of squaring 2x. Now, the expression is equal to y. We might be a bit hasty to place y on the right hand side because we want it to follow what we have there. So we want the next thing to follow. And that is why we might want to put the y on the right hand side. We may be a bit hasty to place y on the right hand side in the order of the statement of the problem. However, for future application, we may place it on the left hand side. You can place it on the left, you can place it on the right. It will not matter in this particular case. But reading through the entire statement of the problem, because this is just a part of it, that's not the entire thing. But reading through the entire statement of the problem, because of where we are leading to, it is going to be more appropriate to place y on the left hand side. There we go. We are not able to see into the future. We read the problem and the requirements dictate that we not only write y on the left hand side, but that we rewrite the expression without brackets. We have the statements right there. We are not seeing into the future. We are not looking into the future. It's just that we had access to the statement of the problem. We are making the adjustment in order that when we get to the next stage, everything will be in phase. By reading the statement of the problem, we know that it is not only appropriate for y to be on the left hand side, but the right hand side will also be more appropriately written without those brackets that we have there. So we have 2x all squared. That is how it is read. It is not read 2x squared. It is read 2x all squared because we are making our intentions clear that we are not just squaring x, but we are squaring 2x. So we are squaring all of 2x. So we should really say 2x all squared. In squaring 2x, we need to square both 2 and x. A common mistake that students make is that they neglect to square the coefficient. Yes, that is a common mistake. We see that ever so often. You have an expression to square, like a term, an algebraic term like this. And instead of squaring the entire thing, only the x is squared. So more often than not, the coefficient is mistakenly not squared. So we need to square the coefficient also. And we have 2 squared is 4, and of course we have our x squared right there. Also, the statement of the problem continues. Determine the 2 values of x that satisfy the equation y is equal to x and the equation derived in the other portion of the problem. So the one that was derived first. And we are going to be relying on memory, although in an examination you would really have the paper right in front of you on which you would have written the expression. So you'll just take a look at it and rewrite it there. But let us glance over. But before glancing over, we should remember that it is y is equal to 4x squared. There we have it. Y is equal to 4x squared. Determine the 2 values of x that satisfy the equation y is equal to x and the equation derived in the first section. So y is equal to x is the one that we are taking from this portion of the statement of the problem. Y is equal to x. And previously, the one before is y is equal to 4x squared. We have a pair of simultaneous equations with both right-hand sides equal to y. It therefore means that both right-hand sides are equal. And if both right-hand sides are equal, then it follows that both left-hand sides must be equal. We have y right there. Y is equal to y. There's no denying that y is equal to y. But since we have y is equal to and y is equal to, it means that these two are also equal. Because in solving a pair of simultaneous equations, one way is to rewrite the system of equations in such a way that we have only one equation in one unknown. In this particular case, if we recognize that since both of them are equal to y, then both of them are equal, then right away we can write an equation involving 4x squared and x. Y is no longer in the picture at the moment. Because y is not present, we just have one equation in one unknown which may be solved immediately. Eliminate x from the right-hand side by subtraction. We have 4x squared is equal to y. The first step in solving this equation is to eliminate x from that right-hand side. We are accumulating all of the terms on the left-hand side, and of course we will be equating to 0. So we will eliminate this x from the right-hand side by subtracting x. And we will keep the equation balanced by subtracting x from the left-hand side also. So consequently, we will have 0 on that right-hand side, and on the left-hand side we have 4x squared minus x. What we have there is a single quadratic equation with that quadratic expression on the left-hand side. And we are about to solve this equation by factorization. So we will factorize the term that we have on the left-hand side, and in factorizing we will take the common factor of x. Take a look at this. Basic factorization, we have a common factor of x, and we will factorize by that common factor of x. So we are taking the common factor of x, and we are using that common factor right here Why do we have it here? Because we are going to take a look at the finer details of factorizing this particular expression that we have. So in factorizing, we will take the common factor, and what do we do? Each term will then be divided by the common factor. So in factorizing, we will take the common factor and we will divide each term by the common factor. Divide each term by the common factor. That's a simple way to simplify x squared by a factor of x. So if we divide x squared by x, the result is x. We typically do this maybe shorthand, or it doesn't matter because the result is accurate and clear. Because x into x squared will give us x, we just remove the index there, and all that we have there is x. Anything divided by itself is 1 because we are dividing x by x, and here we are dividing x squared by x. And of course, we are taking the common factor and dividing each term by the common factor. So let us take the common factor of x, and we will divide each term by the common factor of x as we have it right there. So x into x squared is x. We conveniently remove this index so that x is all that remains, and of course x into x is equal to 1, and there we have the other factor. So one factor is x, the other is 4x minus 1, and that is equated to 0. And by the principle of factorization, we know that if we have the product of two terms, two expressions, two numbers, and that product is equated to 0, one or the other or both numbers must be equal to 0. And it is on that premise that we will solve that quadratic equation by factorization, saying that this one is equal to 0 or this one is equal to 0. So let us go straight ahead. Equate each factor to 0. So when we equate each factor to 0, what will we have? We will have 4x minus 1 is equal to 0, and also we'll have x is equal to 0, so that is already a conclusion. So this factor of x, or this factor of 4x minus 1, will be equal to 0. If x is equal to 0, then we have our conclusion already. And what else? 4x minus 1, that is equal to 0. And if 4x minus 1 is equal to 0, what do we do? Eliminate 1 from this left-hand side by addition, which will give us 4x is equal to 1. Then we will eliminate this 4 by division, which will give us x is equal to a quarter. Therefore, the two values are x is equal to 0 or x is equal to a quarter. Now, we will take a look at the statement of the problem. The statement of the problem did not just say solve the equation, because if the statement of the problem said solve the equation, then we would have to find the equivalent values of y. But the statement of the problem did not say that. The statement of the problem said that we should determine the two values of x that satisfy the equation such and such. So all that we need to find in order to meet the requirements of the examiners is to find the values of x, and that we have done already. X is equal to 0 is one root of the equation, and the other one was worked out to be x is equal to a quarter. There we have them. X is equal to 0 or a quarter. And we are at the end of the solution of the entire algebraic section, which is problem number 2 on the paper. And I hope that you all enjoyed the presentation as I enjoyed bringing it to you. And I hope that all of the expressions, some of the things that are a little bit different from what we are accustomed to, like the negation of a denominator or an expression in which the first term is positive and the second one is negative, that kind of a mechanics that will make our approach very much simpler and will be time and space efficient. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.